Hey, so welcome to the last section, section 3 of Unit 13. We're going to talk about simulations, and this is a great section. Actually, all the last couple sections we've done have been great AP statistics sections. If you've enjoyed these last couple units, then you need to seriously consider AP statistics as maybe your next step in your math career, because here's the deal. As you go to college and you find a major, you're going to find that many majors require statistics. And so if you take it in high school, then you're setting yourself up for a preview of that course, or you could pass the AP test and maybe you could test out of it. But anyways, that's my plug for AP Stats. I think it's the most useful course that we can offer in high school. Now, on to simulations. Here's a question I'm going to pose you. Suppose in a class of 25 unrelated students, just 25, we'll consider them random, all right, random students. What is the chance that at least 2 students share the same birthday? I mean, that's a good question. I think a lot of people think of this intuitively as it's not very likely. But we'd have to figure it out. We'd have to do a lot of work here. Here's our choices if we wanted to answer this probability question. Because there are 365 days, that's a lot, and 25 students, it can get kind of messy. So our options, if we want to figure this out, we could conduct an experiment and actually throw kids into classes and then measure how many outcomes there are. So to do that, we would have to create lots of classes over time. They'd have to be exactly 25 students, and we'd have to measure, how many shared a birthday, how many didn't, and this would take a lot of time and a lot of effort. Okay, so that's the problem with that, but we could do it, but it would just take time and effort. The second thing we could do is calculate the theoretical probability. We just use some of our math rules, right? So we could say, okay, well, student 1 in the class has 1 out of 365 chance with, student 2, but also 1 out of 365 chance with student 3, and then 2 with 3, and then 3 with 4, 3 with 7. It gets crazy, right? Formulas can be complicated and involve higher math. So sometimes we can do that, but it's also very messy. The third option is to simulate an experiment. Interesting. Using a model that's similar to real-life events. This is actually really useful. It's what they use to determine things like how diseases spread, how hurricanes move. They use probability models in computers, and they just run it out, and they run it several times. Most teenagers are, well, I don't say most teachers, but a lot of teenagers will be familiar with, say before the Super Bowl, they come out and they simulate the Super Bowl and they try to find a winner. Usually Madden does that, right? The winner according to Madden. That's a simulation. It's based on probability. They run it out. Maybe they do it 100 times and they see what the result is. Using a model to imitate real life is called simulation. A well-designed model will yield accurate results for a large number of trials. So we can use our calculator. You're going to need a graphing calculator. Probably an 84 is best for this section. Here are the steps for simulation. Number 1, we're going to assign a digit or digits, if needed, to each outcome. You're going to see what I mean with that in a second. Then we're going to simulate many trials using your calculator. So your calculator is going to pull digits out, however we want it to. And we're going to see what the outcomes are. Then we will state our conclusions. So it seems pretty easy, right? I'm not sure we know what these 3 things mean yet. So let's go to our first example, which was the 25 unrelated students. Okay, what is the approximate probability that at least 2 students have the same birthday? So I'm really going to get you some calculator skills in this one. If you love your calculator, this section is for you. So let's first, before we pull that calculator out, let's figure out what we're going to do here. What we can do is we can take the numbers 1 to 365, and let's write those down. I'm going to write them here off to the side a little bit because we're just going to try to conceptualize what's going on. So we have the numbers 1, 2, 3, all the way down to 364, 365. We'll let those represent the days in a year. So if I pull number 1 can represent January 1st. Okay, and then number 2 would represent January 2nd. And we're going to go through the calendar. It gets a little tricky in the middle because, day 100, or was that in March or something? But the last day of the year would be 365. That would be December 31st. Okay, so every day in the year has a number that's assigned to it. Now what we're going to do is we're going to ask the calculator to pick one of these randomly. It's almost as if we take all these numbers and we throw them in a fancy hat, right, on a piece of paper, and then we mix it up and then we pull one out. That'll represent the first student. If we pull a number out, the first student And we'll get a number from 1 to 365, and whatever that number is will represent their birthday. Then we put that paper back in the hat because, if we don't do that, then no two kids will ever get the same birthday. But every student's birthday is independent. The likelihood that you have, a birthday we're figuring is independent of the next kid. They're not related to each other. So we need to put the paper back in the hat. And then we mix it up again. We pull another paper out. That represents the second student. Then we're going to put it back in and mix it up, and we pull out another paper. We're going to repeat that 25 times because the question is in a class of 25 unrelated students. So we need 25 pieces of paper. Each paper will represent a date from either January 1st up to December 31st, one of the days of the year. We're going to then look for repeated numbers. After we put them in our calculator, we'll sort them and look for repeated numbers. If a number repeats, then we know that we pulled out two students, two numbers, and they share a birthday. Then last part, this is important. We have to theoretically repeat this many, many times. And what's nice about computers is you can write a little program and it can do this. You can say, hey, run this 10,000 times. And it's easy for the computer to do it, and it saves us time. And as we do it, we're going to calculate the probability based on what we observe in our simulation. So, number of students who share the same birthday. If there's none, we're going to put a tally here. If we have at least two of the same, have the same birthday, at least two of the numbers, because it might happen more than once, then we'll put a tally mark here, and then we'll figure out the relative frequencies. So let's do that. Let's pull that calculator up. Here is our trusty TI-84 plus CE, whatever that CE means. And we're going to go into the math setting. So start in the home screen, go to the math setting, and you're going to notice probability is actually one of the headings there. So we're going to go over to probability. Now, the function we're going to use is number 5. So I'm going to hit 5, and that's random integer. Now, if your calculator is not updated, it just says random int on your screen, so just pause a second. You'll see what I'm doing here. But if it is updated and you have this screen, the lower bound we're going to make 1, and the upper bound is 365. And then n is the number of numbers that we want to select. How many of these numbers do we want to select? And we have a class of 25, so you know what? We can just speed this up and select 25 all at once. Now paste. If you do not have an updated calculator or you have a TI-83, then when you hit random int, it goes right to this screen. You have to use the comma, which is above the 7. So you can do the same thing. So 1, 365. That's the lower number. That's the upper number. And then we're going to select 25 of them. We're not done yet, though. We're going to be smart. We're going to hit the store button, which is left of the 1. We're going to store all of these numbers into a list. So I'm just going to store it into list 1, which is above the 1. Everybody get that? Pause the video, find those buttons if you need to, but we're going to pick random integers from 1 to 365. We're going to pick 25 of them. We're going to put them in list 1. So let's hit enter. And you see a bunch of numbers here that are selected. These represent the random numbers that were pulled from the hat. And so now we need to see if any two are the same, if there are any repeated numbers. Let's go into our lists here. To do that, we hit the stat button, and then we hit enter. All right, so notice L1 has all these numbers, and it goes down. Let's check it out. I'm actually going to scroll up because that's the shortcut to the bottom. So notice that I'm in the 26th row now, but if my last number is in the 25th. So I have 25 numbers in L1. How am I going to tell? Look, ooh, they're one day apart there. But how am I going to tell if any two repeat? That would take a lot of hard work, a little bit. I mean, I'm not very good at checking. So to make my life easier, I'm going to go back to the home screen. We're going to sort the list. Let's hit the stat button and choice 2, sort, ascending. That means ascending from smallest to highest. We're going to sort. We're going to put L1 there. So we're going to sort list 1 ascending. And when you hit enter, it just says done. Okay, let's go back in, hit stat, hit enter again. Now, no. Awkward silence. Check that out. We have two kids at the top with the same birthday. How did that happen? Now, in your calculator, you're going to get different numbers than mine. Okay, all the calculators are most likely going to be in different places unless they've been reset. My calculator, oh my goodness, I get a 3 and a 3. Again, you're going to have different numbers here because I use my calculator a lot. But look, check this out. I'm going down the list. I'm a little shocked. I'm going to be honest right now. Shocked that my first two numbers were the repeating ones because they were just there in your face. But I don't have any other repeatings. Okay? I just have those 2, 3, and 3. I can't believe that happened. I'm really shocked here. So anyways, we're going to write those down. That happened. That was one trial. We did it one time. So did we have at least two of the same? I'm going to put a tally mark here. How many times do we have to do this? Well, I said many times. What was I thinking? Let's do this 20 times, okay? 20 times. We're going to do this whole process. It is a little bit time consuming. So let's repeat the process again. I'm going to show you how easy this could be. Ready? I'm still shocked. I'm shocked I had 2 3s like that. I'm going to scroll up. I'm going to grab this command. That put 25 brand new random numbers in the list. I'm going to scroll up. I'm going to sort the list. And now I just need to go look at it. See how when it's in your calculator, it's easy to do. I can go look at it, hit enter, and now I have different numbers. I'm going to look for repeats because that represents they share the same birthday. So I'm going to go all the way down to the bottom, looking for the same repeated numbers. Oh, there we go, 360 and 360. They repeated. So I'm going to mark that under at least 2 the same. I'm going to do it one more time because I want to get one where they don't repeat, just so you can see that anything is possible. So how do we do it again? I'm going to quit. I'm going to scroll up, random integer, into L1. I hit enter. Then I'm going to scroll up to sort ascending, L1. I hit enter, and it's just put 25 new numbers into my list. So I'm going to go down and look in this list. This will be my last one. Then I'll let you do it 20 times. As I said, you're going to get different numbers than me. Everybody should get a little bit different numbers. And the only time that that's not true is if we reset our calculators and we all start with the same random numbers. But look at this right here. I have another one, 255 and 255. That is crazy. So I'm going to do this 20 times. You do it 20 times. Pause the video. And that's going to take some time. And then come back with me and we'll see what results we get. So this is what I got when I finished. I did it 20 times. So that's the total number of trials. If you look, I got 5, 9. So in the top, I got 9. In the bottom, I have 11. So that's 20 trials. I did it 20 times. In the relative frequency, so in the top, it's 9 out of 20, right? And that is 45%. So let's call it 0.45. At least 2 of the same happened 11 times out of 20. And that was 55% for me. Now, for you, it's going to be, it might be the same, but it might be a little bit different. It all depends on the random, that's the randomness involved. So this is an experimental probability. It's based off of the experiment. In a class of 25 unrelated students, the chance that at least 2 students have the same birthday is approximately, for me, based on my simulation, 55%. As you're going through and you're checking the homework, please be aware that if you get the same answers I get, something's probably wrong, right? Unless we seed our calculators. That's the only way to fix that, which, you know, we've talked about that. All right, let's try a second example. The maker of one of the most popular breakfast cereals, Zereos, wants to put an Algebro action figure in each of its boxes as promotion. That makes sense if it's called Zereos. If 40% of the boxes contain a breast, all right, so I'm going to write that up here. Breast, 40%. Probably the most popular. I get it. 25% contain a Sully. 20% of the boxes contain a bean. And then the rest contain a Kelly figure. Oh, well, how many is that? So that's 65. That's 85. Kelly figure's 15%. So that makes sense. All right, so 15% right there. How many boxes, on average, would you expect to buy before you had a complete set of all 4 Algebros? And we're going to seed our calculator this time. And that'll help us get the same exact answers here. So if it does ask you to seed your calculator, let's review how to do that. Ooh, just did that experiment. So we want to seed our calculator at 1, 2, 3, 4. So let's do 1, 2, 3, 4. And we're going to store it into, and then we hit the math. We go over to the probability again, and we just hit choice 1. And what that does is that puts our cursor in the exact same place of a random table of digits here, and Long story short, it means we're all going to get to the same answers when we do this, just so we can check that we're doing it correctly. All right, so what are the possible outcomes of this trial? So the possible outcomes are Brust. That's one possible outcome. Oh, goodness. Brust, Sully, Bean, and Kelly. Those are the possible outcomes. And what we want to do is assign numbers. Before we did 1 through 365, because that represents the day and the year. But here we're doing percents. And percents are always out of 100. So what I can do is I can select random digits from 1 to 100. And if I divide those digits out with these proportions, then it'll represent, we can simulate by pulling numbers, and then it'll tell me whether I get, as an outcome, a Brust, or Bean, or Sully, or Kelly. So to do that, you have to make sure you divide these numbers up in the correct proportions. So let's be easy. We'll start easy. Brust, 40%. So if I let the digits, let's let 1 through 40, the first 40 digits, represent Brust. So they're going to represent Brust. Okay, so that's 40 numbers out of the 100, so that'll give me 40%. Now Sully is 25, so that means I need to let, out of the 100 numbers, I'm going to let numbers 41 through 65, because that is 25 numbers, right? That's going to represent Sully. That means I have a 25% chance of pulling out a Sully if there's 25 numbers out of the 100. Let's go to Bean. 20. He needs 20 numbers here. So we're going to let 66 through, we got 85. That's 20 numbers. That's going to represent Bean. And lastly, Kelly would be the last 15 numbers, which would be 86 through 100. So you see what I did there? I divided 1 through 100 up into percents. 1 through 40, that's 40%. Here's 15 numbers. Here's, we got 20 numbers, and here's, oh wait, that's 25 numbers. This is 15. You know what I mean? So as we go through all of these and we set it all up, all 100 digits have to be accounted for. They each have a percent right here. I think we're good to go. Now, does it matter which numbers you choose for which algebra? It really doesn't. It doesn't matter which numbers you select. If you wanted, you could have made Brust, you know, the last 40 digits, which would be, what, 71 to 100? Okay, you could have done that. You could have selected any way you want to, just as long as you state what's going on so that the person reading it knows before you start the simulation. So we answered A, we answered B. Now we're going to show the results of the 20 trials below. So again, make sure that you seed your calculator for this one so we get the same answers. Let's see how we can pull these numbers out. We're going to hit stat, wrong button. We're going to hit math and go to probability and choose choice 5. Okay, now in this simulation, the lower number is going to be 1, but the upper number is going to be 100. I'm going to pull them one at a time here because it's a little more complicated. Remember, the question is, how many of these cereal boxes do we have to buy until we have the complete set of all 4 Algebros? So this can be a little bit tricky. As I'm pulling numbers, I have to make sure I remember what we're doing here. So I'm just going to let, if I pull a Brust out, I'm going to shorthand here. I'm going to call that event A, this will be event B, this will be C, and this will be D. Okay, so I'm going to write down here when we get an A, B, C, or D. So this can be a little tedious. I know, it's a little bit pain in the butt, but let's go through and do this. Hit the math button, go over to probability. For this, it's the same. We're going to use random integer, and we're going from 1 to 100 this time because I'm pulling out, you know, we're representing percents. So 1 to 100, and I'm going to use 1 at a time. So make n equal to 1 because this one's a little bit tricky. And let's pull the first number out. The first number is a 3. So I'm going to write that down. That is a 3. And above that, I'm going to write a 3 is choice A, Brust. So I have an A. And I'm looking for, I can stop when I get A, B, C, D. I need all 4. I hope I left you enough room here. So the next one is 19. Now I already have an A, but I'm going to write that down anyway. Let's do another one. 10. Whoa. Guess who's... I guess we know who the popular Algebro is, Mr. Brust. Okay, so we pulled 3 boxes of Brust out. Don't worry, it's stale. It's getting back at me. The universe is getting back at me here. So that's another 3. We have 4 boxes of Brust. At that point, just throw your cereal away. It's 5 boxes of Brust. This is when you switch to toast. Thank goodness, we get an 80. Oh, that's different. So which one is that? That would be bean, right? So now I have cereal box C. All right. Ooh, wait, what am I doing? We're gonna write down 80. Forgot what I was doing there, I got excited. That is cereal box C. We need to get a B and we need to get a D. So keep going, pause the video, finish the first trial until you get A, B, C, and D. Pause the video, go. All right, so fortunately that we got another 80, crazy, and then we got a 44, and then which is Sully, right? And then a 99, which was Kelly. So how many total boxes did we have to buy in that trial? 1, 2, 3, 4, 5, 6, 7, 8, 9. So that was 9 boxes. So that took a little bit of time, and there are ways you can speed it up because we need to do this 20 times. So let me show you. Here's a suggestion I would do to speed this up. I would probably say this. Let's go to math. We'll go back to probability. I'm going to select numbers from 1 to 100. You know what? I'm going to select, we'll say 100 of those numbers. Paste. And now why am I selecting 100? Well, I'm going to store them like we did earlier in list 1. That's going to put 100 numbers in that list, right? And I don't want to sort them this time, right? Because that would kind of ruin what I'm doing. If I sort them, then all the Brusts would go to the top. But now it's a little easier. I can look at it and say, all right, so how many did it take? And I want to write these down as we go. 58, 36, 2. Like I have the numbers right here. It looks like for the second one, let's write it down. We got 58, 36, 2. So I've written down, these are the boxes of cereal in order. You know, we got a B, we got Sully, then we got a Brust, we got some more Brust, then we got a Kelly, that's unlikely. Then another Kelly, then 64 would be Sully again, and then finally last we get an 81 that represents bean, and that represents all 4 Algebros we finally got. That's 1, 2, 3, 4, 5, 6, 7, 8, 9. So once again, it took 9 boxes. That's a coincidence, but that's what it took. So we need to do this 20 times. So at this point, you know, maybe it's easiest just to do the little trick I showed you. We're going to come back here, scroll up, random integer, put them into L1, and then we can go hit stat, enter, and now we have them. Again, we can look at them, and then you repeat it. So go ahead and complete this box. We'll see if you get what I get or close to it. We shouldn't get we should get exactly the same this time because we seeded our calculator. But you won't, as you simulate more and more, you won't get the same answers all the time, but you should get close. So I'm giving an update here. I'm like halfway through my simulation, by half if I mean a quarter. But I go through and look, trial 4 took forever. It took 13, right? That's not going to fit right here. So I'm just going to put ... until I get to the 88. And then trial 5 took 11. So that's too many numbers. I mean, I understand it takes a lot of numbers here. What you want to do, like, because we seeded the calculator, these should all be the same for us. But what if you hit the button one more time extra, then you get off from everybody? That's okay. So you don't need to have, if there's some point here where your table looks a little different and it'll be different the rest of the way down, that is okay. All right, so I'm going to finish this simulation. I'm just going to look into my calculator when I do it. So here's the calculator. I like to look at it, and if I have the paper next to me, I can make sure that I'm doing it pretty well here. Ooh, see, I just hit it twice there. So I'm going to be off. I skipped one because I forgot to do it. That's a great example. But I can go through and look at it. That's a D right there. That's the one that's rare. So what do we have? A, we have like 62. Let me go back up. I forgot what's going on. So 62 Sully. Ooh, that was a quick one. So that was, this simulation was 72 is a bean. So I got a bean, I got a Sully, I got a Brust, and then Kelly right there. So that one did it in 6. So I'm going to go through, I'm going to complete the table. I'm not going to fill in the trial part. They're going to be a little bit different for everybody at this point. Okay, so I'm back. This is my last trial, number 20. So what do we have? An A. We have an A, a 71. I always have to look at the number. I'm terrible. 71 is C. There's a D. So I need a 41 through 65. And then the way I always do it, I know that's the last one I'm looking for, so I just need a 41 through a 65. There's one right there. And notice how the row number is 16. So that one took 16. Woo. So through my trials, I understand. Here's the deal. Yours is going to be a little bit different probably because we messed it up here. But in mine, the longest one I got 17, and the shortest one I got a bunch of 5s. I did not get any 4s. So the next thing I'm going to do is I'm just going to put all these numbers in a list so my calculator can add them all up. So I'll just use L2 for that. So go ahead and add all those in. Let's start with the ones over here. So we're going to start with 9, 9, 9, 13. Let's put that all in L2. So when you're all done, you should have 20 numbers, right? So my last one is 16 that I put in there. Yours might be a little bit different. That's fine. So then I'm going to quit, and I got to clear that out. All right, so once we clear that out, see, hit the second button, go into the lists. We can go over to operations, and then we can keep on going over to math. Whoops, sorry about that. We go down to 3, and we're going to find the mean of L2, because that's where we put all those numbers. And it says 9.2. The other way is you can add them all up and divide by 20, but all that equals 9.2. Oh, so that's our average. So on average, we have to buy 9.2 boxes to get all 4 Algebros. That's based off of our experimental probability. And again, yours is going to be a little different. Your teacher's going to want to see a little bit of this so we understand that you know what you're looking for. This shows that I clearly know what I'm looking for in the different cereals. But let's write down our answer there. So one clear sentence. On average, you should expect to buy 9.2 boxes to get all 4 Algebros. That is a lot of work. Ooh, I do understand. That is a lot of work. And keep in mind that our answers might be a little different when we do this. This isn't the type of math where everybody gets the same answer, which that might bug some of you. Let's look at our last example. I'm going to help you set it up, but we're not going to run through the whole thing together because this video is already longer than it's long. We'll just put it that way. All right, so read the example, come back, and then pause the video and figure out. It's very similar to the last one. The home team wins 65% of the games. We have a 2-2-1-1-1 situation. How can we simulate this situation to see who wins the NBA Finals? So hopefully you've wrapped your head around this problem. You know, when it says 2-2-1-1-1, that means that the higher seeded team plays 2 games at home first. Then they travel to the lower seeded teams and play 2 games. Then it's back to the higher seeded, over to the lower seeded, and finally the last game out of the 7 will be played on the higher seeded team's court. All right, so we need to just be really clear in how we're organizing this because it is crazy. I let the numbers 1 through 65 represent the home team wins. So whether it's home, the higher seed, or the lower seed, that's going to represent the home team. And 66 through 100 represent the visiting team. So in my first trial, let's set this up so we know what's going on. So I organized my first trial like this. You have a higher seeded team. They will play 2 home games, 2 visitor games, a home game, a visitor game, a home game. Whereas the lower seeded team, they'll be visitors first, then they play 2 home games, then there'll be a visitor, home, visitor. Now I'm going to pull out of my calculator 1 through 65. All right, we're going to play, well actually we're pulling a number from 1 to 100. And if it is 1 through 65, that means the home team wins. So let's see how we can do this. I'm not going to seed my calculator, so we might get different answers here. So I'm going to, what am I going to? I forgot what I was doing. Hit math, go to probability. We're going to pull a random number from 1 to 100. I'm just going to do one at a time because this can be a little crazy. All right. So 82, that represents what? The visiting team wins. So I'm going to circle it. The visiting team won that series. I'm going to write the number right here just so we can reference it later. Okay, back to the calculator. So I hit enter 3 times to kind of speed up my process here, but I got a 37, which is the home team wins, right? So let me mark that. 37. That represents the home team wins. So that's this team right here. So now the series is tied 1-1, right? And what do we get? A 93 and a 98. Those are visitor wins. So 93 and 98. So the visiting team wins here. That's going to be this one and this one. So this team here, the higher seeded team, now has 3 wins to the 1. And then 47 represents the home team. That's this team right here. That represents 4 games won by the home team. It took a total of 1, 2, 3, 4, 5. And I'm gonna write that down. 47 is our last one. All right, everybody understand what's going on here? This is a little tricky one to understand. Okay, so it took 5 games, and the home team won. All right, that was weird because we got those 90s there. Let's do one more trial together. All right, let's try this. So I'm gonna go back. I'm gonna clear this out so I'm not confused. All right, so we're gonna hit enter. That's gonna give me the results again. We get an 81. So an 81 represents the visiting team won. So that's this team right here. Right, then we're gonna hit enter. I'm gonna do it a couple times so I get a couple numbers here. 53, 29, 58. So those are all home wins. Let's write this down. So we got an 81, we got a 53, 29, and then 58. So those are home teams. So that's this team, that's this team, and that's this team. Home team is winning. We need the visitors to win. 89, that is the visitors winning, and we are done. The lower seeded team won here. So in 5 games, this was the higher seeded team wins that one. In this one, it took 5 games, but this question isn't really asking how many games. This question, but we're gonna write it down, took 5 games. But here, the lower seeded team won. That's crazy. So then we would do this 20 times, 20 trials. It is crazy. Go ahead and simulate it out. 20 trials. I'm not going to show it all in the video because that would take forever. So with my simulation going through, and I did it 20 times, and I didn't show every single trial here. That would take forever. But here's the results that I got for each of the trials. In the first trial, remember the home team won because we had 1, 2, 3, 4 wins for the higher seeded team. And then for the second trial, the lower seeded team won because we had 1, 2, 3, 4 wins. Remember the first 1 to 4. So we did that 20 times. Here's what I got. Higher seeded, lower seeded, higher, higher, lower, 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 higher, lower, all the way through the end. I had the higher seeded team winning 12 out of 20 times. But yours might be slightly different. I think it's slightly above 50% is the way it works out. So that's it. Whoa, that is simulations. That's a long video. We're going to have to shorten that up. This is Miss Kelly and Kaiserslautern. Remember, it's nice to be important. More important to be nice. See ya.